Okay, let's talk a little bit about some problem-solving strategies for circuits. Well, really one big problem-solving strategy for circuits. Consider for a moment this problem. We have a circuit that has an unknown resistor, and it's connected to a 10-volt battery. The current through the resistor is measured to be 20 milliamps, so we get an ammeter here. We want to know what is the resistance of the resistor. So this is a kind of fancy looking circuit problem. It's a simple circuit, one resistor, one battery, just kind of two elements. So it's as simple a problem as we can set up. So let's talk about kind of how we want to tackle this. We can break down a basic strategy into five steps. Each step might have possibly multiple sub-steps inside of them, but let's talk through kind of a big plan here. So first step, we want to ID the information you have. Second step, we want to determine what quantity you're looking for. These are pretty much going to be the first two steps of every physics problem ever. Third step, this is now circuit specific. We want to write down a loop equation or equations or node equation or equations. Depending on how big and messy your circuit gets, we may get more loops and more nodes. For this, we have one loop, no nodes, so there's only one equation we can write down. Once we have that equation, we're going to solve it for the quantity that we're interested in. We may need to do a little manipulation to kind of get there along the way. This is big overview, big picture stuff. And then we want to plug in our values and evaluate. So when we're kind of talking strategy, this is the big step that is about circuits. It's all about kind of getting this loop equation done. But so let's go through this and apply this. So first step, ID the information we have. Well, we know we get a 10-volt battery, and we got a 20 milliamp current. So let's see, if I start a little tally over here, delta V battery is going to be 10 volts. My current, and I know there's only one current in a series circuit, is 20 milliamps. All right. Now let's see, step one. That's all the information I got. Step two, determine what quantity I'm looking for. Well, I'm looking for the resistance of the resistor. Not like a rebel base or something, just, I want some resistance R. So R equals something that I'm going to try to find out. Cool. Next, I want to write down a loop equation or node equation. Well, there are no nodes here. There's no place where there's a split in the current, but there is one loop. I'm going to go around like this. And so, let's see, delta V loop. I have a battery. And I have, ammeter doesn't count. It's not an element in the circuit. It's really just measuring stuff. It's like my black box, which I'm claiming is some kind of resistor. And I know that equals 0. Now, I can do one step better than this, because I know from Ohm's law that delta V resistor, if I'm going through this kind of in the usual way, is going to be minus IR. So, this is all of the info that I've got for this problem. Let's see, let's drag this. Nope, that's not going to work well. We'll just slide over this way. So now, let's take a look at this. We wrote down a loop equation. Now we want to solve this thing for the quantity we want. Well, we want R. So let's do a little bit of work on this thing. If I kick IR over to the other side, I'll have delta V battery equals IR. Then I want to get R alone, so I'm going to divide both sides by I. So I'll have R equals delta V battery, which I know, divided by I, which I know. So R equals 10 volts divided by 20 milliamps. But now I got to be careful because milliamps, that's not the base SI unit. Oh, incidentally, solve for the quantity we want, plug in values and evaluate. We jumped right ahead to step 5 here. Well, milli, oh goodness, that's not what I wanted to have happen. Milli, aside from being an excellent musical, Tony Award-winning best musical, assuming it's thoroughly modern Milli, not just some random, ho-hum milli. Milli means 10 to the negative third. So I can replace that milliamps by 10 to the negative third amps. And then I know whenever I do stuff with scientific notation, I can split out the coefficients from the powers of 10 stuff. And then I can also just have the units chilling out over there. So R, this is 1/2, it's 0.5. This, I can kick 10 to the negative third up to the top and make it 10 to the third. And a volt per an amp, probably don't know that off the top of your head, but since everything's in base SI units, I know this has to come out to ohms. And then, if I'm going to do this in scientific notation, this would be 5.0 times 10 to the second ohms, or 500 ohms. So this is kind of our basic strategy. We're going to want to start by, same things we always do whenever we get tackling a physics problem. ID the information you got, figure out what you're looking for. When we're dealing with circuits, we're going to the tools we have really are writing down loop equations and node equations. That's kind of how we organize the information that's given to us. This is an example where we wanted to go through and calculate something. There are plenty of cases where we might just want to logic it out and say, all right, well, if the change in voltage from the battery is equal to the change in voltage of these two resistors added together, then I know that each resistor has to get less voltage than the battery. That's what we kind of saw when we had two light bulbs in series. Each resistor each light bulb got less voltage. It got less energy. It was less bright. I hope that that's Englishly correct. Englishly correct? Wow. Yeah, speaking is challenging. Anyway, hopefully this gives you a better sense of kind of how to start tackling these problems. Again, ID the information you got, ID the information you want, write down your loop equation or your node equation, and then just kind of start organizing it to get the information you're looking for.